Now, for this flipped classroom video, you should have your booklet at this time, and section 1.2. And this is what it looks like. So there is section 1.2. The title is there, so you don't really need to write it again, but if that's what you'd like to do, that's okay. So I've put it there, and then over on this left side it should be blank, and this is where you're putting your PowerPoint slides, the notes of those, and then later toward the end of the lesson we go through the examples. And here is 1, 2, and example 2. For some reason I wrote it twice. Maybe not included in your new booklet. I've modified them a little bit. There's 3 and 4, and then on the next page, let's move it down a little bit here. Yeah, there is 5. And I've included some of those major charts. So what I'm saying here is we get to these notes, I'm saying see the other side, because these properties are listed there in some detail. Now, if you want to write them out on this side, perfectly fine. So in section 2 of Unit 1, we're doing operations, properties, and application of real numbers. Operations, order of operations, property of addition and multiplication. You don't have to write these out. We'll be doing them in sections. Applications of real numbers. All right. First of all, the addition, subtraction, multiplication, and division of signed numbers will be presented. Now, these are some major operations in arithmetic, and I'm assuming you all know this. But you may not know what, when you add two numbers together, and this is for vocabulary, the results are called the sum. Again, you may know this, but if not, write it down, maybe a quiz question. And the numbers being added are called the addends or terms. The addends, the more formal. Now, when we are adding real numbers and the signs are the same, that is, they're all positive or they're all negative, you just add them all up and apply the sign. If it's positive, we don't write the positive sign. But if it's all negative, you have to write negative. Now, when you're doing unlike signs, this is sort of like subtraction in a way. And I'll go over that process with you when we get to an example. Now, for addition, we just went over that. Now, subtraction, we look at these two terms, A and B. When we are subtracting, the A is called the minuend. Again, that's a word you may not know. And the B term is called the subtrahend. So probably we won't use this much, but you may want to have it if this is the quiz question. And of course in subtraction, the results is the difference, where in addition the results the sum. In subtraction, the difference is the result. And the first term, A, the minuend, the second term, B, the subtrahend. Now, one of the interesting things that we could do, though, is we can take a subtraction problem, as we see here, and convert it to an addition problem by saying A plus, and then in parentheses, the negative value. Okay? So often we say we change the sign of the negative and then add. And that's what they're showing here. Now, when we multiply real numbers, the results of multiplying the numbers are called the product. That's the result of multiplying two numbers. And the two numbers that we're using, went the wrong way here, are called factors. So when we multiply factors, which are the numbers involved in multiplication, the end result is called the product. So if they're asking you for the product of something, then you're thinking of the operation multiplication. Now, when we multiply real numbers, if the signs are the same, like signs, that is, two positives or two negatives, the signs are the same, like signs, the results are positive. Now, if you are multiplying two factors with unlike signs, that's one's negative and one's positive, the result is always negative. So these are some of the basic rules, and you had this in elementary school and junior high and high school. We're just reviewing some basic vocabulary here and the results of operations. Now, when we divide real numbers, again, you want to write this out. The two numbers we refer to then as the quotient. So the quotient A divided by B could also be written as a fraction. So if they say the quotient of something, think of it as this fraction. And keep in mind that our denominator, B, can never be equal to 0. We'll be going over that shortly. Now, we call A, when it's set up like this, the dividend. Or if it's set up like this, the number on top, that's the numerator. And B, when it's set up like this, is the divisor. Or set up like this, it's called the denominator. So you want to take some notes. There are some potential quiz questions here. Now, we also say for all real numbers, A, B, and C, if A divided by B equals C, then A equals the product of B times C. A little something to put in your notes. Now, the rules for sign, numbers, and division are the same as for multiplication. If you're dividing two negatives or two positives, that is, like signs, the results are positive. If you are dividing unlike signs, that is, one's negative, one's positive, and you could flip them around, the results are negative. Okay, now in your notes you're going to put example 1 PP. This is something we're going to use to designate to help you focus on the question I'm asking when we're doing the quizzes. So simplify each expressions. You may want to pause and copy them down, and we'll be writing them out here. So here we have a positive and we're subtracting a negative. Well, this is straightforward. 11 minus 8 equals 3. Now, here you have to be careful because you have to do some judgmental calls initially. What do you do first? Well, you have the opposite of a negative will make this a positive. So now you could write that as a second step or just do what I've done. And this is 7. Now here our signs are the same, so our answer is going to be positive. We don't write the positive. And 4 goes into 16 4 times, so positive 4. Now here we are multiplying unlike signs. So a good thing to do is check what will your sign be, your end sign, negative, and then 28. And there are the answers. Now, a new background information, division with 0. In our mathematical system, if we divide 0 by any non-zero number, the result is 0. Because remember, we said b times 0 is 0. And b cannot be a 0. Now, if we are dividing, let me write this one out for you. b, which would be any kind of number, by 0, this, in our mathematical system, is undefined, which they have it right there. Now, the reason for this is, if we multiply b times this and get 0, what would we multiply 0 by? Something here to get b. Well, there's no way to do that. So we say in our mathematical process, dividing any real number that's not 0 by a 0 is undefined. Now, in our next part, we're doing order of operations. That is, when we're doing addition, subtraction, multiplying, is there any special order? And the answer is definitely yes. And we often use this acronym, please excuse my dear Aunt Sally, to help remember the letters of what we're doing in the order of operation. Now, the way this works, the parentheses and exponents, grouping symbols and exponents, from left to right, whatever is in them or they're asking us to do, we do that first. Then we move on. Once we get rid of grouping symbols and exponents, we do multiplication and division as it occurs from left to right. Now, if division is first, going left to right, we do division first, and then multiplication. But this is something that we do next, going from left to right, whichever is first. And we'll see this in examples. And then finally, from left to right, we do the operations addition, subtraction. Now, the P stands for parentheses, but it also refers to any grouping symbol. And take some notes on this. What are the grouping symbols? Well, the most common is the set of parentheses. So you do what's inside that. Another one would be brackets. That's a grouping symbol. Anything inside. Another one, braces. Do whatever is inside. Another grouping symbol that we mentioned earlier was the radical sign. Anything under the radical sign, you do that. That's a grouping symbol. The radical sign is an operation and a grouping symbol. The fraction bar. Anything above is done first. Anything below is done first. It serves as a grouping symbol. Then we have one that we mentioned already, absolute value. These could be a grouping symbol as well. So we think of these has our grouping symbols for P that we do first. Then we would do exponents, then multiplication, division, addition, subtraction. Now they're going to show us that in the next slide as we continue with this. And we've done that. So now we're going to give an example, and in your notes, the blank page part, you're going to put example 2PP, indicating it's part of these PowerPoint slides. So let's do this as is indicated. So we look through here, we have an exponent here, so this is going to be 6 times 4. 2 to the second is 4, plus, minus 4, and then now in parentheses we have to get the sum of this, which is going to be 3. So we're doing our next order of operation from left to right. We've taken care of exponents and parentheses grouping symbols. We're now going to do multiplication division. Well, there's no division, so we'll do the multiplication. This is 24. Well, I left the 5 out of here, so plus 5. Now we do the negative 4 times 3, the multiplication. We don't do this part here first. We do the multiplication. This is going to be negative 12. Now, here we could kind of add the 5 and the 24 and get 29. That's one way to do it. Minus 12. So this is going to be, when we subtract 12 from this, 17. And there were the steps indicating how we got the 17. Now, I said there might be other ways to do this, and you'll see that we could have done, as I was looking at it, I might have subtracted the 12 from the 24 and got 12. And then mentally plus 5 gives me 17. So that would be legal to do, as you'll see that we're going to illustrate that here shortly. And there is a solution. Now, we're going to move into something that's called properties of addition and multiplication. These are often done in any introductory course as one of the first lessons, and we're doing it here. So we're going to use the letters A, B, and C that stand for real numbers. And the first property, and again you have a listing of this in your booklet on the other side, but you want to be familiar with it. We'll call this one number 1. This one number 2, and this one number 3. Now if you're looking at the chart and following it, that's good, or you may want to write it just for extra practice. Now when we add any two numbers together, or multiply any two real numbers together, they give us a real number. This is the property of closure. That when we do things in an operation, mathematical operation, with real numbers, adding them or multiplying, we get a real number. All right, number 2, the commutative property. Here we're saying if we have an add-in A and an add-in B, we could switch those around and get first a B, then added to A. And you might say, well, that makes sense. But there is a property that describes it and gives it legality. It's legal to do this in math, to switch add-ins around. But the name of the property, and this may be a quiz question, is the commutative property, and then of addition. Now here we have factors, A, B. We can switch those around to get B, A. It's legal to do it. So the factors can be switched around. And this would be the commutative property of multiplication. Now, the associative property, I like to write this out too. So I'm going to say A plus B plus C equals A plus B plus C. You're saying, wait a minute, those are identities. These are exactly the same. Yes. Well, how do we make the associative property out of that? Well, we're saying that we could add A and B first, and then add the C. Or we could add the B and C first, and then add the A, and we'd still get the same result. It is legal to do it that way. So the description of the associative property of addition is this. It has to do in grouping, associating terms in different ways. Now, could you also take this BC, switch it around? Sure. That would be part commutative property. Now, how about the multiplicative property? If we had A times B times C equals A times B times C. Again, they're identical. But they're saying you could multiply the AB first, or you could have multiplied the BC first, then the A, and the results are the same. This is the associative property of multiplication. And you'll be asked in your homework, and then later some examples, what property are we dealing with? Let's continue. Now, another property, one of multiplication, one of addition, is the identity property. Now, there is a real number 0, that's the 0 on our number line, such that when we add it to A, whatever A happens to be, we're adding 0 to A, it's just A. So we call this the identity property of addition. You could add 0 to anything and not change its value. So the identity property of addition is a 0 added to anything. Doesn't change its value. And then there is a real number 1, such that if you multiply any number by 1, it doesn't change its value. It's still the original. 1 times any number is the same number. So 0 is the identity element for addition. 1 is the identity element for multiplication. Some of the basic rules. Now, a couple more, and I'm going to move this down so that it gets everything in there. Okay, good. The inverse property of addition and multiplication. Now, the inverse property of addition is the additive inverse. That is, if you have a negative A, add an A to it, you end up with a 0. So the inverse property of addition is adding its opposite number. Now, for each 0 number, there is a real number A, such that when you take, and I'll write this out for you here also, sounds better when I'm doing it, the number A. Now remember, every number is written over 1. If we multiply a number, in a sense that's in a fraction form, by flipping it, that is taking its reciprocal, that would be 1 over A. The resulting value is always a positive 1. That's what they're showing here. Multiplying any number by its reciprocal, its multiplicative inverse is another way of describing that. The product is always 1. So here they have it summarized. Negative A is the additive inverse of A, which remember will equal 0. 1 over A is the multiplicative inverse, that is the reciprocal of A, and it's really over 1. We just don't write that 1 by convention. All right, a couple more rules. We'll be using some of those in the future. Now, I believe this is our last property here. We're talking about the distributive property, and many of you know this, so just you can look at it. Here we have the sum B plus C. We're multiplying it times A. So we multiply A times B, get AB, A times C, and get AC. And then we could also put the factor outside to the right. A times B is BA. A times C is CA. And keep in mind you could switch these around through the commutative principle and move them both around through the principle, the commutative principle. Yes. Okay. Now I want to add one other thing here, because every once in a while you'll see something like this where we have an A in this term and an A in this term. How do we get the A's out of the terms? That is, go backward. And the answer is we do it by factoring. So write that word down. You may know it already, but just write it anyway. The opposite of the distributive principle is the factoring. It's not really a principle, but that's the process, the operation. We factor out the common A and end up looking like this. And we could factor out the A and theoretically going backwards. But mostly we use this form here, where the single factor is in front, not at the back, but that's okay too. All right, let's go on. Again, write this up. This is not in your booklets. In our PowerPoint slides, example 3 PP, PowerPoint. And the record high temperature in a small town was 108. I put that on a thermometer here. And its record low was a negative 43. I put that there. How much greater was the highest temperature than the lowest temperature? So we would find that by doing subtraction. And it would be like 108 minus, now we have to put that in parentheses, a negative 43. This is the tricky part. So we're going from here down to 0, that's 108. And then we're going from 0 to 43, that's 43. So in a sense, the difference is going to be, when we subtract, will be the sum of these two. The opposite of a negative makes this a positive. So that's going to be 151. 3 and 8 is 11. Add 1. Yep. So that would be the difference. Let's go on and see what they show us here. Let's see here. Yeah, we were flipping some slides there, but there it is. Okay. All right, now for these are in your booklet. So you can follow along in your booklets and work out the answers. Now, sometimes the answers, I will put them there for really difficult ones, but otherwise we're asking you to basically do them. So take a moment, do them, and we'll do them too. Both negatives, so this is going to be a negative 9. Both negatives, so this is a negative 16. Now one's positive, one's negative, so we're doing subtraction here. This will be a 3. Again, subtraction of the negative from the positive, and that gives us a positive 7. Now here the negative value is bigger. So the technique, again, you're going to put this in your calculator, it's easy, but subtract the 12 from the 16 and you get a difference of 4. And the larger value here is, absolute value is negative 16. So we use the sign of the larger absolute value, the negative 4. But if you do that in your calculator, this is how it comes out. And you see one is the additive inverse or the opposite of the other, so that's 0. And there they are. Okay, now we're asked to find the difference here. This is subtraction. But again, often we can convert it to addition of unlike sign numbers. So here this would be a negative 8, and a positive 6 gives us a negative 2. Now these are both negative, so we just add them together and get a negative 16. Now here this is a little tricky. The opposite of a negative makes this a positive. So this is going to be a negative 3. Same here, opposite of a negative. This will be a positive 18. And your textbook, and here we're showing all the details of it. I like the idea that they're defining what they're doing. Okay, now we're multiplying real numbers. And again, the rule is like signs, positive, unlike signs, negative. So, looking at this, a negative times a positive will give us a negative, and 9 times 7 is 63. Negative times a positive will give us a negative. 5 times 14 is 70. Negative times a negative gives us a positive. This will be a 32. Okay, we have some easy ones. And of course you can use your calculators. And there are the answers. Now division works in the same way for signs. And again, look at your signs. Determine what the end sign would be. Here it's going to be negative. Here it's going to be positive. Here it's going to be negative. Alright, so this is a 3. This is a 4. And this is a negative 20. And again, check your work. Be sure your signs make sense. And there they are. Now, order of operations, we went over this in some detail. Remember, division of 0, let's go back one here, is undefined. But if you're dividing 0 by any real number, that's a 0. And we've reviewed this. All right, let's get started on this one here. Want to do it in some detail, and actually we showed this. This one we showed already. All right, let's go on. Okay. There's what we're asked to do. So let's do this one together. Now, again, you have to take a moment to write it down. Normally, it's already written in your booklet, or you may want to write it again. And then, what do you do first? Well, in case A, we're going to do the multiplication. And I would suggest that you try it first to see how you would end up. So this is going to be a 6 here. 6 plus 5. This will be an 11. So they gave you an easy one here. All right, B, as we go along, and we had one like this. This is going to be a 4. Now, 3 squared is 9, so 4 times 9 plus 7. And this is 2 plus 8 in parentheses, so this becomes a 10. So this is negative 10. So what do you do first now? Well, we do this multiplication. 4 times 9 is 36. Now I'm going to put the minus 10 here. I switch this around. I'm allowed to do that. And then I'm going to add 7. So we could do it that way or not. So this is 26 after we subtract the 10 plus 7. And then this is going to give us 33. Now, you could have done it the other way too, but again, we don't want to show too many ways here. All right, let's clear this up so we have a little room for letter C here. And what do we do first? Well, what's in parentheses? So this is going to be 2 times a negative 4. Now, here we could leave it this way, or we can actually do this multiplication. This is going to be a negative 44. And let's finish the top here. This is going to be 2 times a negative 4 is a negative 8. So I'm just going to erase this now and put there a negative 8. So this is still on top of this grouping symbol, the division bar. So now I have 5 times a negative 2, which is a negative 10, and a negative 3. So, summarizing this, in my bottom position, I'm going to have a negative 13, and in my top position, I'm going to have a negative 52. Now, you might say, okay, a negative divided by a negative is going to give me a positive. Okay, I got that. But does 13 go into 52? And the answer is yes, it goes evenly 4 times. So the answer to letter C is a positive 4. Now, letter D is a little tricky, so I'm going to write it out for you. Now, you might think you are going to raise a negative 4 to the fourth power, but that would be wrong. Now, if negative 4 was in a parenthesis like that, that would be true, but it's not in a parenthesis. So, what's the protocol? What's the operation that we do here? Well, we have to raise only the 4 to the 4th power. And 4 to the 4th power, I believe, is 256. I'll check that here. Doing it in my head, or remembering it. And then we apply this 1. In a sense, it's a negative 1 times that. Although the 1 is not written there. But think of it that way. So a negative 1 times this makes this a negative 256. So you have to be careful with something like that. What are you raising to the 4th power? Only the 4. Then you apply that negative sign. We had some like this when there were absolute values. It was 6, and then times the negative 1 was a negative 6. All right. Let's clear this up. Oh, here they're doing it this way. Should have looked ahead. So this one would be a negative 4. Now the rule is, if you're raising a negative value to an even exponent power, it's always going to be positive. So this will be a positive 256. But here it was a negative 256. All right, let's go on and do our last one. So, what do we do first? Well, we can do this multiplication, although we should do that first, but this is okay. So this is going to be a positive 24. Negative times negative. Now we have a negative. Now, inside this parenthesis, we have end up with a negative 3 here. And the opposite of a negative 3 makes this a positive. And then we have 4 plus 3, and this bracket is 7. So, we did this, got a negative 3. The opposite of a negative 3 made it a positive 3. 4 plus 3 is 7. And then applying this sign now, this becomes 24 minus 7 is going to be 17. And I'll just check that I'm doing it mentally. Yes. Okay. Let's see how we did. So in some detail, A is 11. We got that. B, again in some detail, 33. C, we said ended up as a positive 4. D as a negative 256. Notice they're showing us that the negative is not raised to the 4th power. But now in letter E, our base is negative 4, raised to the 4th power, which is an even number. So negative times negative is positive, positive times negative is negative, negative times negative is positive. Okay, I gave you the shorthand way. So they're starting there, which is fine. They end up with 17, which is good. Okay, now you could have done this part first, but could have done this theoretically first. Alright, we did go over the properties already, so I'm going to pass this up. And now we're asking you what properties. We're saying that 5 plus 6 is a real number. That's the closure property. Now, notice we have 5 plus 6 plus 8. 5 plus 6 plus 8. The order is the same. We're just grouping them differently. This is the associative property of addition. 8 plus 0 is 8. This is the identity property of addition. Adding 0 to anything doesn't change its value. And then here we're multiplying a number by its reciprocal. The signs are the same. We end up with a positive 1. This is the inverse property of multiplication. Now, notice 4, 3, 6, 4, 9, 4, 9, 3. We've rearranged this, so this shows the commutative property of addition. And this one is the distributive property. Okay. And there they're all laid out, and you want to be sure you are familiar with these. All right, one more example. This is example number 7 here. Raise it up so you can see it, but then we need to raise it down so you can see the part. Now I have the solutions here, and when we are going from low numbers to high numbers, and we're looking for the total, remember it's the sum of this and actually the sum of that, because minus and negative makes these positive. So for letter A, it's 40.13, and letter B, a negative 15.32. And here, this is a positive number, indicates an increase. a negative number will indicate a decrease. And we did one like this. Notice we're subtracting, and then the opposite of a negative number makes it positive. So 214. And that winds us up here. Yeah, I didn't want to make it too long for you. Remember, you can always play it a little faster.